Imagine you're designing a deck, and you're looking to determine the total square footage you will have on that deck. Normally, this would be a simple task of multiplying the length and width, but for some reason you're indecisive on both. But somehow, you know you're going to have both a bench and a planter, and somehow you know exactly how much space the bench is taking up as well as one of the dimensions of your planter. Well, now look at what you've done. You could have just made up your mind on the dimensions of the deck itself, then subtracted the area of the planter and the bench later on. Don't you worry your unprepared little head, because algebra exists. So when looking at a problem like this, it's important not to get flustered. I know how many of you look at that line with an odd angle and immediately give up. You see, it's actually quite easy to account for, so don't judge a line on being anything other than a 90-degree angle, as you'll find a lot of less than favorable lines in life. Now to start off, we will have to write the answer in the form of this. I honestly couldn't find the term for it because I believe there is one, but anyway, first let's analyze a equals x times x minus 4. This is pretty obvious. It's simply the formula for the area of the deck. But before we can do that, we have to account for the lost space from the bench and planter. So, the planter went first in our answer, so we'll place that here first. So these three numbers all make up the triangle and its value, starting with the 2, which is the 2 feet at the bottom, times x minus 4, which is, the wall, and then you have to cut it in half, because obviously those two would give you a rectangle. Once you cut it in half along this line against the theoretical rectangle that it has made, that's how you get the triangle and its value. So with that value, you can then subtract it from the total area of the deck, as well as, the 12 from the bench, which I'm not going to go over because I'm assuming you guys know how to multiply, 6 times 2. I'd hope you know how to multiply that. But it's really rather simple once you get through the triangle bit. Really, it's just a formula that you have to account for. And then past that, it's just subtracting all the other perimeters, multiplying different things by values, 2 values, and then get a value total, and you multiply that value total by the value total. See, the whole problem with it only is that for whatever reason, the person who's designing this deck, I think it was Philip, has decided to not decide on, the dimensions. Then it could have been a lot more simple. You wouldn't have to write it out like this. You could have just, done all the normal stuff that people would normally do, like have a dedicated value for how big your deck is going to be when you're playing it. But no, he didn't, so now we have this algebra problem. But anyway, that's how you make a triangle, and it can be used in other problems too, maybe ones that require an algebraic equation, instead of this one that obviously didn't.